Okay, so now we are going to learn how to solve our radical expressions. So it's similar to simplifying radical expressions and everything, but now we're actually going to have an equation and we're actually going to look to solve this. So now we're going to be getting answers such as x equals 5, a equals 2. We're going to be ending up with some sort of an actual answer here. So let's say I had the equation something like square root of a plus 5 plus 7 is equal to 12. Okay, so as we see, we have an equation here because we see the equal sign. So when we're working with radical equations, we actually want to take kind of like a three-step process here. So step one here is going to be get the radical by itself. All right, we want to get the radical by itself. So what that means is I have to go here and I have to say, all right, where is my radical? So I look here and I say, all right, my radical is right here. So I want to get this radical by itself. So the first thing that I need to say to myself is, well, I have to get rid of this plus 7. Well, in order to get rid of plus 7, we're just going to subtract 7 from both sides of our equation. So here that's going to cancel each other out. So we're going to be left with the square root of a plus 5 is going to equal 12 minus 7 is going to give us 5. So once we've gotten the radical all by itself, no coefficient, nothing added or subtracting onto it, we then work with step 2, which tells me to square both sides. So what that means, to square both sides, I have two sides of my equation here. I'm going to take both sides of my equation and I am going to square it, or raise it to the second power. Now the reason that we do this is whenever we have a square root, the opposite of a square root is squaring. Meaning, if I had something like the square root of 5 squared, the square root and the square will actually cancel each other out, and you'll just be left with whatever is under the radical, or what we call the radicand, if we remember that. So whenever I square a square root, we are left with just the radicand. So if I go back to my problem here, if I square the square root of a plus 5, I'm going to be left with just the radicand of a plus 5. So now I've gotten rid of the square root, which really was the big issue here in solving. I do have to work with the other side, though. But 5 squared, that's a pretty simple problem. 5 times 5 is just 25. And now, the third step, I'm going to get rid of this here. The third step in solving our radical expressions is to now solve for the variable. Get the variable by itself. So if I want to get the variable by itself here, I'm going to just subtract 5 from both sides. This will cancel out. So I'll be left with a is equal to 20. So my answer here would be a is equal to 20. Okay, now what I should always do whenever we solve problems, I should always check my answer. So technically we're going to have a step 4 here, and that's going to be to check the answer. But checking the answer is as simple as taking that, plugging it back into the original equation, and seeing if both sides equal the same thing. So I'm now going to check my equation. I'm going to plug it in. I'm going to have the square root of 20 plus 5, replacing the a with the 20 that we just got, plus 7 equals 12. So I do what's under the radical first. 20 plus 5 gives me 25, plus 7 equals 12. Now we know that the square root of 25 gives us 5, and then 5 plus 7 is 12. So as we see, this checks out nicely. So because this checks out, we know that A is going to equal 20 here. This is exactly what we wanted. Alright, so let's do one more here just to make sure that we understand how we're doing these types of problems. So let's say we had something like 5 times the square root of A minus 3 plus 4 equals 14. Okay, so again, if I go based on my step process that we had in the last video, or the last slide, we want to get the radical by itself. So now the problem with this one is it actually has this 5 times after or before it. So I want to get this part by itself first. We'll deal with the 5 in a second, but I want to get this by itself, so I'm going to subtract the 4 from both sides. That's going to be the first thing that I want to do here. So when I subtract the 4 from both sides, that's going to cancel. I'm going to be left with 5 times the square root of A minus 3, and then 14 minus 4 is going to give me 10. But like we said, we want the radical by itself. We still have this 5 on the outside here. So what that means is I have to get rid of this 5. Well, if we remember correctly, this is technically just saying 5 times the square root of A minus 3. The way to get rid of multiplication is to divide. So I'm going to divide both sides by whatever this coefficient is. Those are going to cancel out. 10 divided by 5 is going to leave me with 2. Well, now what I can do is I can move on to step 2 here, which then said both sides, take them and square them. We want to square both sides because now when I square the square root and the square cancel each other out, and I am left with only what's underneath the radical. In this case, A minus 3. On the other side, I do whatever I have squared. 2 squared, that's going to give me 4. And now I go through with just solving my equation here. I'm going to add 3 to both sides. Those will cancel. And here I'll be left with A equals 7. But again, we should always check. So let's check our work here. I'm going to take my A equals 7. I'm going to plug it back into the original equation. So I'm going to have 5 times the square root of 7 minus 3 plus 4 equals 14. And I want to see if this works. So I work with whatever's underneath the radical first. 7 minus 3, that's going to give me 4. I know that the square root of 4 is 2. So I'm going to have 5 times 2 plus 4. 5 times 2 is going to give me 10. And 10 plus 4 is 14. So it does check out. So I know that I got my answer correct. So I've put 2 more problems up on the whiteboard here, the blackboard I guess you could call it. So I want you now to pause the video, take a couple seconds or minutes, and try to figure out these. Now I'm going to give you a hint with this one here. Remember in the last problem how we divided to get rid of the coefficient? The coefficient of the radical here, it's not 5. So be careful with that. So that's a little hint on that one. But let's see if you guys can do these on your own. Pause the video here, and then hopefully when we come back, you'll have the correct answers. So here are the answers for the 2 problems. For the first one, we should have gotten r is equal to 2. As we see here, we need to get the radical by itself. So I subtract the 3 from both sides, getting the square root of 7r plus 2 equals 4. Squaring both sides to get rid of the square root. So I'm left with, sorry about that, 7r plus 2 equals 16. Subtract the 2 from both sides, 7r equals 14. Divide by 7, r should equal 2. Now over here, I gave you that little hint that 5 is not the coefficient. See how we're adding it to the radical? The coefficient of the radical is actually a 1. So really, this is just like if this 5 was on the end here, and because it's positive, we're just adding it onto it. So to get rid of the 5, we're going to subtract the 5. That'll get rid of that 5 there. We're going to have the square root of g minus 3 is equal to 6 minus 5 is 1. Square both sides. 1 squared is still just 1. Add 3 to both sides. My g will equal 4. So hopefully we got both of those correct. Alright, so let's try one more of these. So let's say we had a problem like the square root of k plus 1 equaled k minus 1. So here we actually have a variable on both sides here. Now the good thing is the rules, they don't change. The rules for this do not change. Step 1 is to still get the radical by itself. Step 2 is to then square both sides. And step 3 is to just solve. So I'm going to do that. In this case, I don't have to do anything to get the radical by itself. It's already by itself. So I'm going to move directly to step 2 and say square both sides. So this side here is easy. When I square a square root, I take just whatever is underneath the radical. So this is just going to be k plus 1. But on this side here, this is going to be a little bit different. We are now squaring a binomial. If we remember back to the beginning of chapter 8, whenever we square a binomial, if I have k minus 1 squared, this is the same as saying k minus 1 times k minus 1, and I'm going to have to double distribute here. So this is going to end up being k squared minus k plus 1, which will then simplify to be k squared minus 2k plus 1. So we have to be a little bit more careful when we see that there is a variable on both sides, or when we're squaring something like that. So now we have k plus 1 equals k squared minus 2k plus 1. So now we have a problem. Now we have to solve this. Well, we should remember that we can solve this, but we had 3 steps to solving this as well. The first step to solve this type of equation was to make one side equal to 0. So I'm going to have to make this side equal to 0 first. I'm going to have to subtract k and 1 from both sides. Alright, if we remember correctly, when we're solving quadratic equations, something that has a k squared and a k in it, I have to make the one side equal to 0 first. So I want to bring all of this over to this side. So when I cancel these both out, this side becomes 0. The k squared is going to stay the same. Negative 2k minus k, that's going to be negative 3k. Now, positive 1 minus 1, that's actually going to cancel itself out for us. So this makes it a little bit easier for us to solve. Well, now, once we're at this part here, now we're asked to factor. So we actually have to factor this. Now, let's think back to what we were doing right before we left. Sorry about this. Let's think back to what we were doing before we left. This was a factoring problem where we could factor out a GCF. If I look at both of my terms, what do they both have in common? They both have a k. So that means I can factor a k into my GCF. Then I'm going to take each of my terms divided by the GCF. K squared divided by k, that's k. Minus 3k divided by k, that's 3. And then for my last step, once I factor it, then I take each of my factors, set them both equal to 0, and solve both of them. This one's lucky enough, I don't have to solve anything here. Here I have to add 3 to both sides. So I end up getting k equals 3 and k equals 0. But again, there's a little bit of a problem here. When I get multiple answers, I have to check my answer. Now, we should have been checking our answers the whole time. I've said that since the beginning, that we should be checking our answers. It's very important to check your answer if you get two answers here. When we have two answers, we have to check. All right, when we don't check this, we have a problem that's called extraneous solutions. Now, extraneous solutions could be a huge issue. So what I have to do is I have to take both of my answers here, and I have to plug them back in. So I'm going to take my my k equals 0, my k equals 3, and I'm going to plug it in. So I'm going to plug in the 0 first. So I'm going to have the square root of 0 plus 1 equals 0 minus 1. 0 plus 1 is 1. 0 minus 1 is negative 1. The square root of 1 is 1. And here I get 1 equals negative 1. But this is not correct. 1 doesn't equal negative 1. So this here, this is what we consider to be an extraneous solution. Meaning, yes, when I solve it, I get this, but it doesn't work. It doesn't make sense. So this is not an answer to my solution. Now, I should definitely check the other solution. I should check the positive 3 as well, because that could also be an extraneous solution. So let's check that. If I were to go and I check the 3, I would have the square root of 3 plus 1 equals 3 minus 1. Square root of 3 plus 1, that becomes 4. 3 minus 1 is 2. And the square root of 4 is 2. And in this case, 2 does equal 2. So we're actually okay with that solution there. So this solution is good. This is an extraneous solution. We have to pay attention when we get a problem that looks like this, that we have to check our answers. It's very, very important. Alright, so let's try one more of those where we have a variable on both sides of the equation. So let's work with one like this. Let's say we had the square root of a minus 2 plus 4 equals a. So as we see, variable on both sides of the equation, so we know that we're going to have possibly some sort of an extraneous solution. But the steps don't falter. The steps are always exactly the same. I need to get the radical by itself first. In order to get the radical by itself, I want to subtract 4 from both sides. So when I subtract 4 from both sides, those will cancel. I'll have the square root of a minus 2. And here, I'll just have equals a minus 4. So now that I have the radical by itself, I'm going to go to step 2 and square both sides. Squaring the square root will give us whatever the radicand is, a minus 2. But squaring our binomial, that's going to be a minus 4 times a minus 4, which I have to double distribute. A times a squared. A times negative 4, negative 4a. Negative 4 times a, negative 4a. Negative 4 times negative 4, positive 16. Combine our like terms, we get a squared minus 8a plus 16. So that's what's going to go on this side here. A squared minus 8a plus 16. Now I go and I simplify. Well, sorry, I don't simplify anymore. I realize that I have a quadratic function over here, meaning I need to make this side equal to 0. So I need to subtract the a and add the 2 to both sides. Those will cancel. Those will cancel. This side is going to end up being 0 equals. I'll have the a squared. Negative 8a minus a is a negative 9a. Plus 16 plus 2. That's going to give me plus 18. So here, this is where we would factor. Now remember, the last time when we factored in the last problem, all we had to do was look for a GCF. But this is a trinomial. When we have a trinomial, we have to work with our trinomial method, meaning, look at the back term. We want to find our factor pairs of 18, meaning two numbers that multiply to get 18. So 1 and 18, 2 and 9, 3 and 6, and that looks like it. But remember, it's got to equal positive 18, so it could be both of these numbers are positive, or both of those numbers could be negative. So we could have negative 1 and negative 18, negative 2 and negative 9, and negative 3 and negative 6. Then I have to go through them and say, well, which one of these pairs will add to be negative 9? And when I go through all the pairs, this pair right here, negative 3 plus negative 6, that's going to get me negative 9. So that means that this whole trinomial can factor to be a minus 3 because of the first one, and then a minus 6 because of the second one. Now again, it still equals 0. Now the final thing that I have to do here, now that I have factored it, I'm going to take each one of my two factors, I'm going to set it equal to 0, and I'm going to solve. So I'm going to take the a minus 3, set it equal to 0. I'm going to take the a minus 6 and set it equal to 0. And I'm going to solve both of these equations. So here I'm going to add 3 to both sides. So I'll have a equals 3. Here I'm going to add 6 to both sides. So I'll have a equals 6. But we have to remember, here we must check our solutions. We cannot leave it and just say both of these are correct. Because maybe they are. Maybe only one of them's correct. Maybe neither of them are correct. So I have to check them both. So I'm going to start by checking the a equals 3. I'm going to plug it back into my original equation. So I'm going to have the square root of 3 minus 2 plus 4 equals 3. 3 minus 2 is 1. The square root of 1 is 1. 1 plus 4 is 5. Well, it's pretty obvious that 5 does not equal 3. So this again, this is an extraneous solution. Alright, this does not count. I don't know why that 3 is not highlighting like the A, but that's fine. This is an extraneous solution. So that doesn't work. But I could check the 6. Maybe the 6 works. Plug in the 6. Square root of 6 minus 2 plus 4 equals 6. 6 minus 2 is 4. The square root of 4 is 2. And then 2 plus 4 is 6. And this one checks out. So we have to make sure that we are checking our answer. But again, like I said, guys, you may find that both of these answers don't work. That can happen. If that's the case, if both don't work, then we have no solutions. It could be that both of them work. If that's the case, then both are correct. So you could have one answer, you could have two answers, or you could have no answers. There is always the possibility of that. So here are two more problems that I'm giving you again. Again, pause the video, try these two problems out, and then once you unpause the video, we'll see the answers and the work here shown. And again, if you need any help, you can follow along with the work that I put up here. But please pause the video, give this a couple minutes, try these on your own, and see if you got them correct. So as we see, in the first one, there is no solution. If we go through the problem here, we don't have to move anything, so we start by squaring both sides. Square root of 6a minus 6 squared, we just take the radicand, which is 6a minus 6. Again, sorry for that. And then we square our a plus 1, we get a squared plus 2a plus 1. We need to get this side to equal 0, so we subtract 6a, and we add 6 to both sides. So we have 2a minus 6a gives me a negative 4a, a 1 plus 6 gives me 7. And now when I'm looking at this trinomial, I look at the factor pairs of 7. The only factor pairs of 7 itself are 1 and 7, or negative 1 and negative 7. But none of those add up to give me negative 4, so this here is a prime trinomial. It can't be factored. So if it can't be factored, we can't find a solution. So this one would have no solution. Moving on to the other one here, same concept, I square both sides. So 2a squared minus 121 is equal to a squared. I'm going to subtract the a squared from both sides. I get a squared minus 121 equals 0. Now this one's a little more difficult because we have to realize that my middle term here that we would add to b would actually have to be plus 0a. Meaning we want our two numbers here to cancel each other out. Well, the only factors of negative 121 are negative 11 and 11, which do add up to be 0. So that works perfectly. We separate it into a minus 11, a plus 11. We solve those, we get negative 11 and 11. But when we check, the 11 works. The negative 11 doesn't work. So my only answer here would be 11 and not negative 11. So hopefully this helped in understanding solving our radical equations. Okay, it's basically a 3-step process. Get the radical by itself. Then we want to square both sides. And then we want to solve. If we end up where we have variables on both sides, before we solve it, we have to bring everything to the one side and then factor. So hopefully we understood what happened today. Yeah, I know. I got a new program, so I'm kind of excited about what I have here. But, yeah, hopefully we understood everything.